So here we assemble 11 8 and 5 liter engines. We produce here 52,000 units per year and we employ 800 people.
Hey everyone, today we are near the city of Lyon in France and we have been invited to get a guided tour through the Renault Trucks engine plant. Let's go. Here we are inside the building and we have a very kind gentleman here with us that will give us the guided tour through the factory. Can you introduce yourself a little bit, please?
Pleasure. I'm Patrice Berger-Perrin from Renault Trucks Corporate Communications and I'll be your guide today.
Awesome. Thank you so much for your time and that you will guide us through this 100 years old building, as you said, right?
Exactly.
So can you tell us more about
please
everything?
Follow me. So you are in one of the oldest buildings of Renault Trucks that's been designed and built from 1916. And to give you an overview rapidly of our history, it all started with those two guys, our famous ancestors. We have Marius Berlier from Lyon, who created his first engine in 1894. And at the same time, you had Louis Renault, who created his first car in Paris in 1898. So imagine that they were the two start-uppers at the time. They were fond of mechanics and of the blossoming automotive industry. So they created cars, engines, and they started their own companies. They developed their own companies into a car business, truck business, special machines business. And they both gradually built empires. Berlier started his business in Lyon and he needed room, so he came to this place and bought 1,000 hectares here. There were only lands and farms, and he progressively bought all this place because his idea, he had a great ambition. He wanted to monitor production from steel down to the final truck. So he integrated a lot of activities through years here. And this place was first designed to build cars and engines. And so it is still producing engines today, and this is what we will see during the tour. Here we have the Berlier car number 2. Number 2, 1897. Imagine that there were no less than 150 car makers or automotive makers here. Of course, a lot of them died. Others survived. Berlier survived, of course. And they were famous around here because of the environment that is pretty demanding. We have hills, mountains, and the Lyonnese manufacturers were famous because they had to, they built robust cars, robust engines that would last and never break down. So Berlier was famous for that. And so this place assembled cars until 1939, and here you have a copy of one of the cars that were assembled here. 1923. But actually it's working, it's operating. You may start it and go with it. And here you have a sample of all the engines that have been built. Most of them have been built here through years, and you have especially this first Berlier diesel engine from 1931.
4-cylinder, 7.2 liter. Nice.
So the plant today is assembling 11 liter engines like this one, and 8 liter engine like this one, and another 5 liter that we have here. Again, we have here a Berlier truck, 1926. Berlier, for World War I, designed a very sturdy and reliable truck that was called the CBA. It was designed to carry troops and equipment to the front. And it was famous because it would never break down, or more or less than competitors. And it was called the Indestructible. CBA, the Indestructible. And from this basis, Berlier developed further models like this one, 1926. And here we have a special truck. Actually, it's a dream truck. This truck was designed in 2004. At the time, the Renault car and the Renault truck design bureau were working together. Even if we already were part of the Volvo group, it was 2004. And they were asked, designers were asked to imagine what could be the best truck ever for drivers, regardless of industrial feasibility, commercial feasibility. And they imagined that this could be the best truck ever. So you see, of course, very streamlined lines, everything hidden, no cables, no tubes, everything hidden under the body. For the driver, they imagine a very roomy and comfortable cab with huge windshields, natural light coming from the roof, inside screens instead of a standard dashboard, of course, and they even imagined that cameras could replace mirrors. And this is what we are. It's happening now, yes, of course. We created a lot of deception actually with this truck because everybody wanted it. Actually, it was operating. It was coupled with a trailer, but it was pure stylistic and communication exercise. It was a hit, but we created again a lot of deception because everybody wanted to buy one, and we said unfortunately, no, we can't. It's not for sale. So here, it has been renewed in 2004 to have the current operations. So here we assemble 11 8 and 5 liter engines for Renault Trucks, of course, but also for the other brands of the Volvo Group, including Volvo Trucks, Volvo buses and coaches, Volvo construction equipment machines as well, and Volvo Penta marine engines. We produce here 52,000 units per year, and we employ 800 people. 20% of female workers in this workforce, 27% of them into management, and that's it. So we have 3 assembly lines, one for the 11 liter engine, the one which is behind me, one for the 8 and 5 liter engines, and we have a third line which is called the conversion line, through which go the engines that need specific equipment, namely the marine engines that need specific components and the construction equipment engines. At the back you have spotted the logistic zone, which is critical actually, because we have 100 people working there. They of course manage all the parts and components for the engines. We unload 30 trucks per day. We of course they check the incoming components. They store them and they prepare them for production, for having this just-in-time delivery of components and parts to the line. And here we have the start of this 11-liter engine assembly line. So we get the blocks from a Volvo Group unit. And on this first section, we will assemble all the internal components of the engine. And you will see that it is mainly automated. We have 15 robots and 32 different automated operations. Why robotized? Just because we need here a high standard of quality in the assembly. So robots are far better than human to do so. So we get the blocks. The first thing that we do, we put this on every engine. It's a chip which is loaded with information about the engine, and which will be scanned all along the way to give instructions to robots and to operators. The engine will move along the line, and they will also go back and forth to be equipped with the different components. We have at the back two sub-assemblies operations. One for a kit made of the liner, the rod and the piston, and another one for the cylinder head. A very complex line, automated line for the cylinder head and injectors. So this is the liner, the rod, and the piston. And this will form a kit that will be assembled into the sub-assembly operation. The first robot here will add the O-rings here, and then at the back end of the will assemble the complete kit. You may see at the back the kits made of the liner, the piston, the rod. You see emerging the rod that has been cut. And the robot here will pick those kits and insert them into the block. It will repeat the operation 6 times, 1 per cylinder, of course. And the robot will apply a pressure of 50 kilos per square centimeter for perfect insertion into the block. You may see the cylinder heads coming from the back, from the sub-assembly operation. They have been prepared and they are sent to the line. And here, the robot will pick a gasket, place it on the block, then pick the cylinder head and place it on the block as well. Next operation is a tightening, controlled tightening of the cylinder head to the block. So we have a specific machine that performs tightening in 3 turns, torque and angle tightening from the inside to the outside to guarantee a perfect sealing of the gasket and the block, and the cylinder head to the block. When robots are not needed to get the quality standards that we expect, we keep adding people. 99% of them are hired as temporary workers first, and we do train them. So they undergo a 3-week training. First, they are given theoretical and practical information on the task they have to perform. Then they are in pair with a senior colleague for 1 week, and then we check if they have acquired the right skills. And then we may keep them as temps for quite a long period of time, just to be sure that they are at the level that we expect. And we recruit them from any background, not specifically from the automotive sector.
So people, they really don't need experience from the automotive?
No, it's not specifically needed. We just need engaged people, and that's all we need actually. So then we have a couple more of tightening operations. Then we have 2 robotized lines here for the setting of the rocker arms, setting of inlet, exhaust, and engine brake. The robots are duplicated here. If one breaks down, another
can take over
may cover immediately. Critical operations there and given to robots.
I wanted to ask, like, this factory runs on a 8-hour shift, or
it's a 1 shift, okay, and 8-hour shift. Yeah. And actually we reached the end of this first part of the line. All the internal components have been added. The last ones are the flywheel housing and the flywheel. And here the engines are fitted with you see this specific gray plate on top. It's a connecting tool that will make it possible to connect the engines to this yellow automated guided vehicle. So the engines will be transferred to the second part. Second part of the line is the place where we will add all the external components, pumps, filters, manifolds, and so on. Contrarily to this first line, it is 100% manual. And on each side of the line, you have those picking stations where we prepare parts to be delivered to the operators. So here again, we have mistake-proofing systems, the same that you may have seen in Bourg-en-Bresse. We have what we call the picto-light system. On the shelves, you have a lit button with a specific color that tells you where to place the parts, in which box to place the parts. You press the button, a little screen gives you the exact number of parts to be picked. Pick them, put them in the box, and then you deliver the box directly to the workstation, either by pushing a standard trolley or with specific guided robots again. So we have reached the end of the 11-liter assembly line. We perform here some final quality checks. We have quality check all along the process, from the logistic zone, where we check the parts that we are receiving from the suppliers, and then you have checks all along the way. We have quality gates to pass, and when completed, the engines go to a final step, which is cold testing. The engines will be disconnected from the automated guided vehicles, placed on a specific sledge, and they will be filled with oil, 30 liter, 35 liter of oil, and introduced into a specific testing booth. And there they will be connected to a drive system that will make run the internal components into oil, just to check if there is no undue friction between elements. And then, after cold testing, the engines go for painting. So why do we paint? Of course, we paint to protect from corrosion. And we also paint for identification purpose. As we build for several brands, each brand has its color. We paint the engine except some spots that mustn't be painted, of course. So this first step here is critical. It's masking. And you see, we will protect all the parts that mustn't be painted. It takes a lot of attention and precision. And again, here we have mistake-proofing systems. You may see specific bolt plates that are hanging. On those plates, you have a drawing or a picture of the engine on which are indicated the spots where protection has to be placed. Then we have two painting lines, two painting booths with two robots in each. It takes 3 minutes to paint an engine, to fully paint an engine, and then 30 minutes to dry it. There we will remove the masking, remove the protections, and again a final check to see if what was to be painted is actually painted, and then it's sent for shipping.
So this is the very last station of the
Very
engine,
last station, yeah.
and then it just goes to the...
It goes for shipment. Shipment to the factories, or for as parts,
Yeah.
yes, as spare parts for customers in some places.
I believe we can end it here. Yeah. The whole tour. It was really impressive. Thank you so much.
You're welcome.
For the tour.
No, it's always a pleasure.
And we will see you at the next episode.